Hello, I hope you're doing well. In this video, I want to talk about how to use integration to figure out the area between two curves when there's actually more than one region. So let me get started with this. So in this particular problem, I have the two curves, x cubed minus 7x, 1. Another curve, 2x squared minus 2x plus negative 5. So one of the things I want to do is I want to figure out the intersection. If I don't know the intersection points, I really can't even do anything. And again, I'm going to use Mathematica to do this. So really quickly, let me shift over to Mathematica. So again, clear your variables. F of x is the one function I want to use, g of x is the other function I want to use, and the intersection points, I need to figure out where the outputs are the same. So using a solve command, I get three nice values. -2, 1, and 3. So those are my intersection points. Now I know I'm going to want to plot this so I get an idea of what things look like. So I'm going to choose -3 and 4 as my plotting domain because -2, 1, and 3 are contained between -3 and 4. Now I may have to change this if the picture doesn't look quite right. This is just a choice I'm making at the moment. I may have to do some minor correction. So evaluating this, I wind up getting the plot that looks like this. Now, I know one of these curves is a parabola and the other one is a cubic. So I don't have to go through my test value stuff, but I have it written down on my page. And what I do know from this is that I tried to copy the picture nicely. That's the best I can do. I know that the cubic function is on the top of the quadratic function in the region from -2 to 1. But it switches. The parabola is the top function, and the cubic is the bottom function on the interval from 1 to 3. If you are unsure of that, you can do some test value. Now, I'm not going to do this in Mathematica right now, but you need to pick a value between -2 and 1. I chose -1.5. You could have chosen 0. 0 might have been the easier case. But I'm going to take this -1.5, I'm going to plug it into F. I'm going to plug it into G and look at the outputs. On this interval, I know F is larger than G. So for this interval, I am going to look at F minus G. And this is going to be my height. But on the interval from 1 to 3, let me pick a test value of 2. When I plug it into F and plug it into G, I get -5 and -1. So in this particular interval from 1 to 3, I get a height that looks like G minus 8. Since I have different functions for the height, I need to take the region from 3 to -2 and break it up into two pieces from -2 to 1. That's why I have this integral here. And then another region from not -2, my bad, 1 to 3. And I need to evaluate both of these intervals. So let me run to Mathematica really quick and just demonstrate this one more time. So what I need to do is I need to put in a definite integral. And again, I did that by going to the palette, Advanced tab, clicking on the definite integral. And I have a lower bound. Well, what was my lower bound? My lower bound was -2, and my upper bound was 1. Now that was for the first region. And in that first region, I know that f of x is bigger then g of x. And remember to put parentheses around both. And my variable is x. So I'm going to do this in two different stages. I will evaluate this. And I know for this part, I get 63 over 4. What about for this? Well, I'm going to be a little lazy here. I'm going to copy this. I'm going to paste it. And I need to change the -2 to a 1. And I need to change the 1 to a 3. Well, that's because I'm in this region right here, from 1 to 3. But my functions, they flip-flop because when I looked at the graph and determined all this, they were in the opposite order. Let me evaluate this, and I get 16 over 3. So I'll write down 16 over 3 here. And then I just need to add them together. And again, I'm going to be a little lazy. I'm just going to put them on the same line and put a plus in between. And I get 253 over 12. So the area between the curve that I gave you has an area of 253 over 12. I broke this problem up into two parts. And you need to do this. You need to look at which curve is on top of the other, in which region and which interval. I hope this video was helpful. If you have any questions, send me an email. Have a good day. Bye.